Hi everyone, welcome you to this presentation on sizing the charge controller. This one marks the end in this series of PV installations. Okay, so according to standard practice, the sizing of a solar charge controller is simply to take the short circuit current of the PV array and then add 30% of that, or that 30% is basically a constant of 1.3. So you multiply the short circuit current of a PV array by 1.3 and then multiply the number of parallel paths. Okay, so that's the formula. Solar charge controller is basically given by the short circuit current of the PV and then multiply by 1.3, which is an increment of 30% of the short circuit current, and then multiply by the number of strings. So how do you determine strings? So strings are basically, for example, these modules connected. An arrangement of modules connected in series makes up a string. So these on top, they are making one string because they are connected in series, and these down there, they are also connected in series, they make up a second string. But for such an installation, this one has got two strings. So you need to know the short circuit current of a module, and then you multiply 1.3, which is an increment of 30% of the short circuit current, and then you multiply by the number of strings. For this scenario, this would be 2. An example: the diagram below shows a solar panel connected in series parallel. Calculate the size of the charge controller to be connected. Okay, so we have these panels or modules. This one and this one are connected in series, making up one string. This one and this one series, one string. This one series, one string. This one series, one string, and then they have been connected in parallel like that. So for such an arrangement, we've got 4 strings. Okay, the information given is that the PV module specifications are: we've got the maximum power 110 watts, you've got the maximum voltage 16.7 volts, maximum current 6.6 volts, open circuit voltage 20.7 volts, and the short circuit current 7.5 amps. So in determining the size of the charge controller, what is of interest to us is simply the short circuit current. Okay, so the solar charge controller will be given by 7.5, which is the short circuit current, that, and then we need an increment of 30%, which is basically multiplying that by 1.3, and then you multiply by the number of strings. So for this one, we have 4 strings. When you do that multiplication, you're going to have 39 amps. So for such a system, you need a 39 amp charge controller. But if you go on the market, you may not find the 39 amp. You may find maybe something like 40 amps. So you go to nearest to that. Okay, so this marks the end. Thank you for